So, how is it that we solve that traveling sales problem? How is it that we optimize the best solution to a problem when we need to, cut the cost to the smallest cost, or we want the shortest travel distance, or whatever it is that we're working through? Okay, so what's that circuit with the lowest cost? This unfortunately does not have an easy answer. There's only one method that absolutely guarantees you have the lowest cost, and that's the brute force method. And that's the one that basically looks at every single Hamilton circuit in a graph, a complete graph, and then determines the total sum of the travel time or the total cost or whatever, and then you take the one that is the cheapest. Okay, well, we did just one small example with 6 vertices that would have 120 different possible circuits, and so you can imagine the amount of time and effort it's going to take. And 6 vertices isn't very many. If you have a lot of things to do, if you are the mailman, for example, and you've got to get to every house, or you're the UPS driver and you've got to get to 50 houses on your route, and you don't want to backtrack and you want to take the least amount of time, finding an optimal solution can be nearly impossible. Okay, but there are 3 methods that are listed here. We're going to look at them each kind of one at a time, and I'm going to leave it up to you to read through the instructions before we do each one. Okay, we're going to first take a look at the brute force method. This is the one where that optimal solution is guaranteed. Okay, so the first thing is you need a complete weighted graph for the problem. Then you list all the possible Hamilton circuits. It can be a really large number, like we did one example on the previous page. There would have been 24 of them with 5 vertices, 6 vertices, it's 120, so it's going to grow pretty quick. And then you find the sum of the weights of the edges for each of those circuits. The one with the minimal weight is your optimal solution. So we're going to look at that brute force method here, going between some cities in Illinois. So a student lives in Peoria, and they want to visit some different colleges during spring break. So we're going to use the brute force method. So there are 4 vertices here. So just as a reminder, that means there's going to be 4 minus 1 factorial, or 3 factorial, which is 6 different Hamilton circuits. Okay, and in each case, we're going to start in Peoria. So I'm going to use Peoria. I'm going to use the letter P. For Chicago, I'm going to use a C. For Champaign, I'm going to use, actually I can't even use a P, can I? I'm going to use an M for Champaign, and then I'm going to use an S for St. Louis, okay, just as we go through these. So without listing any numbers right now, I could start in Peoria, then we could go to Chicago, then we could go to Champaign, we could go to St. Louis, and the student could go back home to Peoria, okay? You could start in Peoria and go to Chicago, then instead of going to Champaign, go to St. Louis, then Champaign, back home to Peoria. You could begin in Peoria, travel over to Champaign, then north to Chicago, down to St. Louis, and back to Peoria. Or you could go from Peoria to Champaign to St. Louis, up to Chicago, back to Peoria. Or you could go from Peoria to St. Louis, to Champaign, to Chicago, back to Peoria. Or you could go Peoria to St. Louis, to Chicago, to Champaign, and back to Peoria. Okay, now in each of these cases, what we need to do is figure out the cost of traveling in that order. Okay, so for this first one, Peoria to Chicago, that's 100, or not a cost, sorry, these are distances. 167 miles to travel from Peoria to Chicago. From Chicago to Champaign is 136 miles. From Champaign to St. Louis is 181 miles, and then back to Peoria is 169 miles, for a total of 653 miles traveled. If we move on to the next scenario, starting in Peoria, driving to Chicago, 167 miles. From Chicago, going to St. Louis at 297 miles. Then going over to Champaign, 181 miles. And then from Champaign to Peoria at 89 miles. you will find we've traveled a total of 734 miles. If you go through the next scenario, again, you'll kind of see the pattern we've got going on here. From Peoria to Champaign, that'd be 89 miles of travel. From Champaign to Chicago, 136. From Chicago to St. Louis, 297. And from St. Louis back to Chicago, 169, for a total of 161 miles. And continue that same thing, okay? And you will find out that going from Peoria to Champaign to St. Louis to Chicago back to Peoria is also 734 miles. That going from Peoria to St. Louis to Champaign to Chicago to Peoria is 653 miles. And then last but not least, this last route is another 691 mile route. The reason you've got duplicates is because if you look, they are the same route, like this 653, for example. This is the same route, just in reverse order. So if you read one from left to right and then read the next one from right to left, it's the same thing, okay? So in this case, the minimal distance traveled, so the minimum distance is going to be 653 miles. That's the best we can do. And we know it's the best we can do because we've tried out all of the possibilities. There are no other possibilities. We've listed them all. This is the brute force method. But again, you add one more vertex to this, okay? You decide you also want to visit Normal, Illinois, and you throw in a fifth visit or a fifth city to go to, then you have to list out 24 different circuits. If you listed another one, you're going to go to Carbondale to check out Southern Illinois University. You've got 120 circuits to do. So it gets a little tedious, but it works every time. In the next video, we're going to explore the other two methods, the nearest neighbor method and the sorted edges method. So before you even start the next video, I strongly recommend that you read through each one of those carefully so that you've kind of prepped yourself, and I'll remind you at the start of the next video to read them through as well.